You know, sometimes a single invention can completely change the way we see everything. Today we're talking about something from way back in 1668 that did just that. It took our view of the heavens, which was honestly a blurry, distorted mess, and snapped it into stunning focus. This is the story of Isaac Newton's reflecting telescope, and it's about so much more than just a piece of tech. It's about how one brilliant idea literally redefined our place in the universe.
So let's start with the big question, right? Think about the mid-1600s. You've got guys like Galileo making these mind-blowing discoveries, but then progress just kind of stalls. They hit this incredibly frustrating wall. What was it? What was this invisible barrier that was stopping them from seeing deeper, from seeing more clearly into the cosmos?
And I mean, just look at this. The difference is absolutely night and day. On the left, that's what the best astronomers had to work with. A blurry, fuzzy mess with these weird rainbow halos. And on the right, that's the sharp, crisp, clear view that Newton's idea unlocked. This wasn't just a little upgrade. No way. This was the solution to a huge crisis that had been holding back astronomy for years.
Okay, so to really get why Newton's invention was such a game changer, we gotta dive into what the problem actually was. We need to understand this crisis in stargazing. Let's talk about the massive headaches that the first telescopes, the refracting ones, were giving everybody. All right, the number one enemy, the main culprit, was something called chromatic aberration. It's actually something Newton himself figured out with his experiments. See, when you pass white light through a lens, it acts just like a prism and splits the light into a rainbow. For an astronomer, this was a nightmare. It meant that every star, every planet you looked at had this annoying, colorful fringe around it. Seeing any kind of real detail was pretty much impossible. And as if that wasn't bad enough, there was a whole other problem called spherical aberration. The issue was, back in the 17th century, the only way they could really make lenses was to grind them into a spherical shape. But here's the thing about physics. A perfect sphere doesn't actually focus all the light to one single sharp point. It's kind of like looking through a slightly warped magnifying glass. So you've got the color fringes, and on top of that, the entire image is just inherently fuzzy. Ugh.
You can just imagine how desperate they were getting. Their only workaround to try and reduce all these distortions was to build these absurdly long telescopes. I'm talking monsters up to 50 meters long. Can you picture trying to aim a 50-meter-long tube at a tiny dot in the sky? It was clumsy, it was unwieldy, and honestly, a pretty terrible solution to a really fundamental problem with the technology. So astronomers were completely stuck. It seemed like making a better lens was a dead end. The technology had hit its limit. And that's when Isaac Newton, fresh off his famous experiments with light and prisms, had this just completely radical idea. What if you didn't need a lens at all? What if you just got rid of it?
This was Newton's brilliant insight. He realized that, yeah, a lens bends light and splits it into a rainbow. But a mirror? A mirror just reflects all the colors of light in exactly the same way. So if you use a curved mirror to gather the light instead of a lens, boom, the whole color fringing problem, chromatic aberration, it just disappears. Problem solved. And the design itself was just so clever. First, you've got this polished metal mirror at the back. Its job is to gather the light, and right away, the color problem is gone. But then, how do you see the image? Well, he put a second, smaller flat mirror up near the front at a 45-degree angle. This little mirror grabs the focused light and bounces it out the side of the tube to an eyepiece. The result? An incredibly compact but powerful telescope. Get this, his first one was only 6 inches long, but it was just as powerful as a 6-foot-long refractor. That's amazing. So, how exactly does this thing work? It really is an elegant machine. Let's follow the path the starlight takes to get to your eye. It's actually a really simple 4-step process. Okay, step 1. Light from a star or planet comes into the open end of the tube. Step 2. It travels all the way to the back and hits that big, curved primary mirror. Step 3. That mirror reflects the light and starts to focus it, sending it back up the tube where it hits that small, angled secondary mirror. And finally, step 4. That little mirror kicks the light out the side straight into the eyepiece. And that's it. No big lens at the front, no color fringing, just a clean, sharp image from reflected light. Okay, so this is where things get really exciting. With this amazing new tool, it was like humanity had been given a brand new pair of eyes. That blurry wall we talked about,
It didn't just get pushed back, it got completely smashed down, and the discoveries just came pouring in, completely redrawing the map of our own cosmic neighborhood.
And just look at how fast the discoveries started rolling in. About a century after Newton came up with the idea, an astronomer named William Herschel, using a reflecting telescope he built himself, found a whole new planet, Uranus. I mean, think about that. This was the first new planet discovered since ancient times. It basically doubled the size of our known solar system overnight. And he wasn't done. He went on to find new moons orbiting both Uranus and Saturn. The floodgates were well and truly open.
So what made all this possible? Well, this chart really tells the whole story. It comes down to a simple problem of engineering. You can only hold a glass lens by its edges, right? If you make it too big, it's just going to sag under its own weight and distort the image. That's why they were stuck at around 5 inches. But a mirror? You can support a mirror across its entire back. This meant you could build them big. By the late 1700s, reflecting mirrors were hitting almost 50 inches across, while lenses were still stuck in the single digits. It was a whole different league. And you know, the impact of this thing went way beyond just astronomy. This one invention sent ripples out into science, into industry, and it fundamentally changed how we as a species saw ourselves and our world.
So on the science and tech side, just the need for better and better mirrors kicked off a huge revolution in precision manufacturing and optics. And Newton's basic design, it became the standard, the blueprint for basically every large research telescope ever built since. Seriously, from his time all the way to today. And his whole process, see a problem, think up a solution, build it, test it, that became like the poster child for the scientific method.
But it was way more than just a scientific tool. This thing was an engine for real societal change. It sparked a whole new industry of people making these optical instruments. It also became this powerful symbol for the age of Enlightenment, proof of what human reason could achieve. And maybe most importantly, by showing us a universe that was so much bigger and more complicated than anyone had ever dreamed, it completely changed our perspective on who we are and where we fit in. So after all this, what is the real, lasting legacy of that beautifully simple idea Newton had back in 1668? Well, the truth is, it's a legacy that we still point at the sky every single night.
And that's the truly beautiful thing about it. The design is so powerful, yet so simple. It's so effective and straightforward that it's still the go-to design for thousands of amateur astronomers in their backyards. But at the exact same time, the core idea, using a giant mirror to catch light, is the foundation for the most powerful professional telescopes on the planet, like the massive Keck telescopes. From the backyard to the mountaintop, it's all Newton.
And that really brings us to the big takeaway here. See, Newton's story isn't just about building a better telescope. It's about a way of thinking. When he hit a problem that seemed impossible, he didn't just tweak the old solution. He threw it out and came up with something completely new. It really makes you wonder, right? What are the blurry problems we're facing today? What are our own versions of chromatic aberration? And where or who is that next mirror of genius going to come from?